Now I am going to explain some numerical problems in optical fiber chapter. So first problem is an optical fiber has a core material of refractive index 1.55 and the cladding material of refractive index of 1.50. Okay, the light is launched into it in air medium. Calculate its numerical aperture. Calculate its numerical aperture. So the information given. So what is the given data? First we will write that given data. Right? The refractive index of the core. Okay, the refractive index of the core. So which is represented by the letter N1. So N1 is equal to, the value is 1.55. 1.55, right? And then the refractive index of the cladding material, which is represented by N2, which is equal to 1.50. 1.50, right? In which medium the light is launched? In air medium. Okay, so for the refractive index of air is equal to 1. Okay, and then calculate its numerical aperture. We have to calculate the numerical aperture. Na is equal to what? So first the formula required. Formula is Na is equal to, numerical aperture is equal to root of N1 square minus N2 square. Okay, this is the formula. So we have to remember this formula to do this problem. So Na is equal to, numerical aperture is equal to root of N1 square minus N2 square. So now we have the value of N1 and N2. Directly we can substitute in this formula. That is root of 1.55 square minus 1.50 square. Okay, so by using the calculator we can get the answer is 0.391. So this is the answer for numerical aperture. So numerical aperture is equal to 0.391. Numerical aperture will not have any units, so that we can write directly. Na is equal to 0.391. I hope you understand this problem. So next we will go to the second one. Now see this second one. Calculate the angle of acceptance of a given optical fiber if the refractive indices of the core and cladding is 1.563 and 1.492. 1.498 respectively. So what we have to calculate? Acceptance angle. So first we will write the given data. Given data. The same information like the previous problem. So the refractive index of the core is represented by N1, which is equal to 1.563, and the refractive index of cladding is N2, which is equal to 1.498. Right? How to calculate the acceptance angle? We have to calculate the acceptance angle. Acceptance angle is equal to how much? Okay, so for this the formula for acceptance angle is acceptance angle is equal to sine inverse of Na. Sine inverse of Na. So in the previous problem only we have discussed the Na formula. So sine inverse of, what is the formula for Na? Root of N1 square minus N2 square. This is the formula for Na. So the formula required is acceptance angle is equal to sine inverse of Na, and then we have substituted the value of Na, numerical aperture value, that is root of N1 square minus N2 square. So we have to substitute the value of N1 and N2 in this. N1 is equal to 1.563 whole square minus 1.498 whole square, right? So by using the calculator, if you find, we can get sine inverse of 0.4461. Okay, after this we will get 26 degree 30 minutes. Actually this is the angle. So angle acceptance angle is represented by theta. So theta is equal to 26 degree 30 minutes. 26 degree 30 minutes. In this way we have to calculate the acceptance angle. So in the previous problem about numerical aperture, the second problem about the acceptance angle. Okay, so let us go to the next problem. The next problem is calculate the fractional index change for a given optical fiber if the refractive indices of the core and the cladding are 1.563 and 1.498 respectively. So here we have to calculate the fractional index change, right? So now listen, given data, again the same, refractive index N1 is equal to 1.563 for core, and for refractive index for the cladding is equal to 1.498, right? And then if we have to calculate fractional index change, which is represented by the letter delta. Okay, what is the fractional index change? So now the formula for fractional index change, delta is equal to N1 minus N2 divided by N1. So this is the formula required to calculate the fractional index change. Okay, so now we have the values of N1 and N2. Directly we can substitute in this formula. So what is N1 value? 1.563 minus 1.498 divided by again N1 value 1.563, which is equal to 0.0416. Okay, so this is the value of fractional index change, 0.0416. Okay, so now we completed the third problem. Let us go to the next one. Calculate the numerical aperture and acceptance angle for an optical fiber with core and cladding refractive indices being 1.48 and 1.45 respectively. So already we have discussed the formula for numerical aperture and acceptance angle. The same thing we are going to use here. So the core refractive index is 1.48 and the cladding refractive index is 1.45. So first we will write the given data. First one is N1. N1 is equal to 1.48, that is the core refractive index, and N2 is equal to 1.45, that is cladding refractive index. Okay, and then we have to calculate numerical aperture and then acceptance angle, which is represented by the letter theta. Right, two things we have to calculate. So first we will find the numerical aperture. So what is the formula for numerical aperture? Root of N1 square minus N2 square. So directly we can substitute the value here. Root of N1 is 1.48 whole square minus 1.45 whole square. So by substituting the values we can get the answer of 0.2965. So this is the value of NA. So after finding NA, directly we can calculate the theta, that is acceptance angle. Theta is equal to sine inverse of NA value. So what is the NA value? Finally we got sine inverse of 0.2965, right? So we will get the answer of 17 degree 15 minutes. 17 degree 15 minutes. Okay, so numerical aperture as well as acceptance angle we calculated. So numerical aperture, there is no unit. For angle, degree is the unit. So 17 degree 15 minutes, right? So next we will see the other problem. See here, this problem is little different. Let us see. An optical fiber has a numerical aperture of 0.20 and a cladding refractive index of 1.59. Find the acceptance angle for the fiber in water which has refractive index of 1.33. So here what is the thing we have to calculate and what are the information given? Let us see one by one. So first information is numerical aperture value they have given, and then cladding refractive index they have given. Okay, and next the light is launched into the fiber in water medium, its refractive index is 1.33. So how to calculate this? Okay, so let us see one by one. First we will write the given data. So given data, numerical aperture NA is equal to 0.20, right, and the cladding refractive index, that is N2, is equal to 1.59. Okay, and then in which medium they are launching in water medium, so which is represented by N naught. In the first problem I mentioned for air medium N naught is equal to 1, but for water medium the refractive index is 1.33. Okay, so now acceptance angle formula, we have to calculate the acceptance angle, find the acceptance angle. So theta is equal to, what is the formula actually? Sine inverse of NA, sine inverse of NA. Okay, so here NA is equal to sine inverse of NA is equal to root of N1 square minus N2 square. Actual formula is divided by N naught. Here N naught for air medium means it becomes 1. Okay, but if it is the different medium we have to include the N naught also. Okay, so that point you have to remember. For air medium, okay, for air medium Na is equal to root of N1 square minus N2 square if you divided by N naught actually, but for air N naught is equal to 1. That is the reason we have taken this formula as root of N1 square minus N2 square, but for air medium. But when we come to the other medium, so this N naught to be included. Okay, so now substitute all the values. Sine inverse of, actually here root of N1 square minus N2 square is numerical aperture. Directly we can substitute that value 0.20 divided by N naught, that is 1.33. So by substituting this we will get the answer sine inverse of 0.151, and by substituting this we will get 8 degree 39 minutes. So the acceptance angle is 8 degree 39 minutes. So what is the main thing you have to remember? The numerical aperture formula for all the medium is, this is the formula. Na is equal to root of N1 square minus N2 square divided by N naught. Actually for air medium generally we will discuss, that's what N naught is equal to 1 for air. So we are not, that means we are not remembering about this N naught. But for other kind of medium if you are using, this N naught to be included. So they mentioned water here, that is the reason we included N naught here, and the water refractive index is 1.33, that also we substituted over here. Right? So I hope you understand this problem. Let us go to the next one. So this problem is about loss in the optical fiber. So now see here, a signal of 100 milliwatt is injected into the fiber. The outcoming signal from the other end is 40 milliwatt. What is the loss in decibels? Okay, so just we will draw the diagram to understand this. This is the optical fiber. Okay, the signal injected into the fiber is 100 milliwatt. So here they are injecting the signal. So this is 100 milliwatt. Okay, 100 milliwatt, and the outcoming signal, so outcoming will come from the other end, which is 40 milliwatt. Okay, so what we are injecting is the input. Okay, what we are receiving is the output. Okay, so this is the power input, so we can write it as P in. Okay, and this is the power output, so we can write it as P out. Right? So what is the formula to find the attenuation? So now here we can write given data. Power in is equal to 100 milliwatt and power output is equal to 40 milliwatt. Okay, next formula for finding the loss, actually attenuation loss. Attenuation loss is equal to, listen carefully, minus 10 log of P out divided by P in. P out divided by P in. Its unit is decibel. Right? So minus 10 log of P out by P in. So these two values we have to substitute in this formula to get the loss. So minus 10 log of, what is the P out value? 40 milliwatt divided by input is 100 milliwatt. Okay, we will get the answer in decibels. So by substituting this in the calculator, we used to get 3.98 decibels. So this is the loss, attenuation loss. So 3.98. 3.98 is the answer. Okay, please go through this. If you have any doubt regarding this problem, you can ask me in the comment box. Thank you everyone.